Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app, and we'll keep sharing great conversations. This is your host, Dan Turchin, advisor at Insight Finder, the system of intelligence for IT operations, and CEO of PeopleRain, the AI platform for IT and HR employee service. And we've published over 100 episodes, and I got to say, I've been looking forward to this one for at least the last 50. Rob May is what I'll call an AI provocateur and the author of the always entertaining Inside AI Weekly, to email newsletter, but also the Investing in AI podcast. Rob's unique takes on AI technology and culture are always insightful. His recent list of annual predictions for 2022 spanned topics from AI on the org chart to AI regulation to the rise of non-neural nets. Go read them if you haven't yet. Subscribe to the newsletter. Rob's a venture partner at PJC. He's also the CTO and co-founder of Dianthus. Previously, Rob co-founded the conversational AI company Tala and co-founded Backupify before it was acquired by Datto in 2014. To be honest, I have no idea what we're going to discuss today, but I assure you it will be entertaining and we'll all leave a little bit smarter. If you're not already following Rob on Twitter, he's at Rob May. And without further ado, it is really my pleasure to welcome Rob to the podcast. Rob, welcome to the show, and let's get started by having you share a little bit more about your background.
Yeah, thanks for having me, Dan. So my background, I trained as a hardware engineer. So I used to do FPGA and ASIC design, and that's how I got my start. Went to University of Kentucky, and after I graduated, went to work for Harris Corporation in Melbourne, Florida. I had a great time down there, but to accelerate my career forward, I got into sales engineering, business development, and eventually went to work for a startup that went under during the financial crash. So we were working, we were doing well, we were hitting all our milestones, and the economy was falling apart. And so we didn't, couldn't raise any more money. And at that time, I started a company. When that company shut down, I decided to start something myself, and that company was called Backupify. We did backup for cloud computing applications. So we built that company to 10 million in revenue and sold it. Had a really nice exit there. Probably should have held on to it because, looking back, was 7 or 8 years ago now, and we were the number one player in the space at the time. The number 4 player is now a unicorn. So probably sold that too early. Then started doing a lot of angel investing, and also started a company in the AI space called Tala that built support chatbots. Tala was not as successful. Good technology, wrong go-to-market. We ended up merging that in with another company, so that's still going. The technology is still doing something. In the interim, I had built an investment portfolio of about 70 angel investments that I had done, mostly AI and robotics focused. And so I got pulled into a venture capital firm as a general partner. And that was PJC. It used to be called Point Judith Capital after Point Judith in Rhode Island. I loved it. I thought I would end my career there. But after 2 years, I was doing some work on our thesis about machine learning and e-commerce. And I came to the conclusion that a lot of the value in the e-commerce space was not going to accrue to machine learning tech tools. Similarly, during that research phase, I came across Thrasio and Perch and some of those Amazon FBA roll-up companies, and basically decided, well, what if we became this new kind of company where we built software, but we built machine learning software for e-commerce companies, but instead of selling it to those companies, we acquired these small and mid-sized e-commerce companies with debt, let them use our software, grow them faster, et cetera. And so that became Dianthus. So I initially put the team together, PJC seeded Dianthus, et cetera. And I just fell in love with it and decided to leave and be the full-time sort of founder CTO, which was not my expectation to go back to the operating side. But, when you're glutton for punishment, I guess you're stuck with it. So that's what I'm doing now. I'm still a venture partner at PJC. I still do a lot of, investing both personally and through them on the AI side. Still write the newsletter and do the podcast, but my full-time day job is focused on Dianthus.
Every week when I read your newsletter, there always seems to be some kind of contrarian take on the state of AI. So to start the conversation, what do you think is holding back AI adoption? Is it technology? Is it tech talent? Is it market demand? Is it something else? Where would you go with that?
It's a couple of things, right? One is there's a very large gap between the newsworthy AI and production level system AI, right? So you read these like wild things that come out of DeepMind or OpenAI, and not always, but most of the time, they're actually things that are nowhere near production ready. Obviously, there are counterexamples. GPT-3, is something that you can like legitimately use in your application now. But what happens a lot of times is they publish this fancy new thing and it sounds incredible. Nobody can replicate it. You can't get access to the code. You don't have a team or the processing power to do it. And so people get these ideas to do these grandiose AI projects rather than these like things that could actually matter day to day. And the grandiose ones that get people excited aren't actually feasible yet. So that's one problem. The second problem is to put AI into some products doesn't always work if you think of it just as an add-on. And so the example I would give you is in the late 1990s, when the web came around, people already had a graphic design process and they used it for flyers and documents and catalogs and things like that. And so if you were a big company and you had that process, and I actually saw this, people would they would use the graphic design process to make a web page. And they would give that piece of paper to an HTML developer and say, hey, can you turn this piece of paper into the website? Well, that's not really what you want to do because the web's different, right? You can have something that's much longer than a sheet of paper, right? It can scroll down for an infinite amount of time. You can have dynamic links. You can update the information regularly. You need a new process that accounts for that information architecture, that dynamism. And that's where we are with AI, right? So a lot of the things that you could teach AI to do, the thing that's holding them back is a lack of labeled data. To capture a labeled data set, you would need people who are doing a task somewhere to do that task differently so that somehow they label data as they're doing that task. And people don't want to change how they work if they can avoid it. They particularly don't want to do something extra. And in many cases, because you need so much labeled data, if you were going to do it as a company, like we're doing this at Dianthus, right? Sometimes we're collecting data for stuff that we expect we'll have to collect for 1 to 2 years before we'll be able to show any results from the data collection. It's a combination of those like workflow factors, cultural issues, people's fear and misunderstanding of AI. I think all those things are holding it back. And there's a little bit of a few practical issues with the idea that a lot of it's getting easier and easier to do AI in terms of being able to execute on a model because you have TensorFlow or whatever, but still not everybody can do it. And more of the secret sauce needs to be abstracted away into tools and packages, right? So an engineer who knows a little bit about machine learning, but doesn't need to know the mathematics of neural networks or how to tune hyperparameters to actually go, make something work.
So you and I have been in and around AI for the enterprise for a while, and I'd contend that what is constraining adoption of AI in the enterprise is poor data quality and poor data quantity. So unlike, let's say, a DeepMind or an Amazon or Microsoft, Twitter, Facebook, et cetera, we contend with a small data problem. We don't have a big data problem.
Right.
What's your perspective on how we get enterprises to adopt AI by overcoming those data challenges?
Yeah, that's a great point. I don't know that it manifests itself. The one thing I will say, I don't know that executives are sitting there saying like, oh, we don't have the data, let's don't try this necessarily. I think the way it's manifesting itself is in a lot of failed proof of concepts where like a lot of people don't realize like IBM Watson took a lot of crap. And granted, maybe they overpromised and oversold some things here or there, but when you dig into a lot of those, I have some firsthand knowledge of some of those projects. And a lot of times it was the company that was trying to buy the project that realized as they got in there, they didn't have the data to do what they wanted to do, right? Or the data, there wasn't enough of it. Maybe it was formatted lots of different ways. And so the expense to bring that together in a clean, easy format was going to be too much. So there were a lot of issues there. There are a lot of tools. Turns out this is a really, really hard problem to solve. It's actually easier to solve on the machine side where you're trying to build machine learning models off of data that's generated by other machines for other, use cases. When you try to do it with something like CRM data, which are like, oh, that's customer data, it should be fairly standardized. No, it looks different in almost every company, right? Slightly different. Humans enter it into the CRM. They want to do it in different ways. They want to set up their CRM in different ways. It turns out like if you've ever even tried to like merge a CRM when you've acquired another company or something like that, man, I mean, imagine having to do that at scale across millions or tens of millions or hundreds of millions of records to train models. This problem of data formatting and data quality is a really, really big, hard problem to solve. And it's not one, there's a handful of like people in the world who really like that kind of stuff, but there's really not very many, and they're hard to find. So yeah, I think it's a big problem. Some people are trying some interesting machine learning approaches to it, and I don't know how successful they'll be. At some point, definitely, but I don't know when. And I think the other thing that's working is you talked about small data AI. There is some research on small data AI, and there will be more small data AI projects long term. There hasn't been a lot of an incentive to do that initially because the companies that have had the resources to drive AI, I mean, business 101 is you play to your assets and your strategic advantage. Google, Facebook, Amazon, Apple, data is a big advantage to them. So they're incentivized to explore big data strategies, right? Not small data strategies that would help the rest of us. But it's conceivable, given what we know how the human brain works, that small data AI is possible under certain circumstances, right? I mean, if you have a toddler, you don't have to show them 10,000 examples of coffee cup for them to understand what a coffee cup is. And so it's one of the areas that I think we've shown the least amount of progress compared to what I would like to see, and but I'm very hopeful for like where the world's going and what I think we'll get to in the next decade at least. I think we'll make big progress on small data AI. But in terms of how the enterprise adoption problem gets solved, I'm not sure where you bite it off first, right? You've got to solve the data problem. You've got some culture and workflow issues. You've got a general misunderstanding sometimes, going back to my printed out paper, web version analogy. Sometimes you just got these issues of people don't really understand what's a good problem for machine learning and what's not, and where should they look to apply it. So you have a lot of different problems to solve, and people are chipping away at pieces of them everywhere. And so I just, hope it gets better and better and better. As some companies become really good at becoming AI first companies, they will start to lead the way, I think, for everybody else.
It's hard to not have the conversation about AI and data without talking about what it means to responsibly use that data. To what extent do you think these ideas or regulatory frameworks about the ethical use of data is or will constrain the advances in AI technology?
Yeah, that's a good question. I mean, I've thought a lot about, well, if I understand your question correctly, about rules around data, one of the big arguments has been that, like, well, China's going to surpass the US in AI because China doesn't care about data privacy, and they're going to, they're just going to record everything and have all the data sets. It's true to some extent, but I think we're still so much in the beginning in understanding what data we need, how much we need for different types of problems, that I think that the number of problems where we're going to say China has an advantage because of their lack of privacy laws is going to be relatively small, at least on the really, really important stuff. And then, and then we're also starting to see what's most interesting to me on the data side is really starting to get edge data, right? Putting AI on edge modules, vehicles out in the world, robots that are doing things, right? New types of sensors that are being developed, and starting to figure out with those data sets, what kinds of things can you predict? What kind of things can you automate? What kind of things can you do in the world that you couldn't have done, previously? And so I think while I definitely have a worry about, the issues about bias are very real. The issue about, data quality in a lot of different ways are very real, but I'm not sure they're the most serious issues around AI at the moment. I think, like, I'll give an example that I wrote about in a newsletter a couple of years ago. It just, having access to all this data changes some of the options that are available to algorithms. So to give you an example, if you and I both use Waze, right? And Waze learns every day, I leave at 8 o'clock to get to work at 8:30, whenever COVID's over, right? And we go back to the office. I leave work at 8, I get there at 8:30. You normally leave at 8:15, you get there at 8:45. Those are standard commutes for both of us. What happens if one day I happen to be a little bit early? I get in the car at 7:57. You get in the car at 8:17. Does Waze say, well, Rob's actually got a little bit of extra time, I'm going to route him a slightly slower way because he can take it, and Dan's going to be late otherwise, so I'm going to send Dan the faster way? Like, what does the algorithm start to optimize for? Does it keep optimizing for each of our individual commutes, or overall, is it a utilitarian kind of thing where, hey, I just want to make sure that the greatest number of people get to work on time based on what I know about them and when they should be at work? And then that feeds back into user behavior, right? Which is, hey, wow, somebody learns that you get the best routes if you leave later than your normal start time, right? Or something like that. So you get all these weird issues, or maybe it determines a different thing. Maybe you're worth more to Google from an advertising perspective, so you get the best routes, right? Like, how, as these systems start to have more data and influence more lives, the choices that they can make around how they optimize the outcomes, I mean, it can blow your mind, some of the, ethical issues that can arise from that.
What's incredible to me is that we're entrusting some of these decisions that could have potentially, global social impact, cultural impact, lives could be at stake, to junior developers, with an undergrad degree writing algorithms, at Google or Microsoft. What considerations, or what's the responsibility of big tech to kind of rein in how, the owners of these algorithms can manipulate data, often in, to unintended and have unintended consequences?
Yeah, I'm not sure they're ready for it, right? And another example I've given in talks sometimes is, for a long, long time, if you're a civil engineering major, you have been required at most degree programs to take an ethics course, because you can't say, let's skimp on this concrete, save a little bit of money, because if you're building a bridge or building or whatever, people could die, right? So But, I was an electrical engineering major, and to my knowledge, most double E's, most computer science majors are not required to take an ethics course. And so you have these complicated issues now that are in some ways novel, ethical issues that society's going to have to face. And we don't have people that even have number one, they don't have even a grounding in what are the different types of ways that you can ethically make a decision, right? There are multiple perspectives to take. There are multiple ways to think about what it means to be ethical. It's not always a clear right or wrong answer, and it depends on, how much you value different types of points of view, things like religion, things like social constructs, etc. But we can't even have the conversation, right? Because people aren't necessarily qualified in most cases, and they don't even see that as part of their jobs. That's what I think is dangerous. And that's where I'd like to see the big companies, lean in a little bit, is do some broader training around ethics. Not just talking about, they're doing a lot about data and bias and all that kind of stuff, but just really laying a framework for how do you make ethical decisions to put intelligent machines out in the world, I think is a big area where I'd love to see them lean in and take everything more seriously.
We've explored the topic of AI explainability on this show quite a bit, including we had Krishna Gade, who's the CEO of a company called Fiddler, which is an AI explainability platform. And we've explored this topic of if anyone who's using AI in their technologies is required to make sure that the outputs or the automated decisions are explainable, then presumably there's kind of a higher ethical standard that will be built into the development methodologies. To what extent do you think AI explainability, how far does that go toward addressing some of these ethical concerns?
Well, it definitely helps. But even explaining why you made a decision, you can still run into different problems, right? Because you could, so let's say you had a credit scoring algorithm and you don't even include race in the algorithm. It doesn't mean that the machine might not figure something out about, people that live in a certain zip code, right? Oh, wow, it basically picks up on the fact that there's a bunch of people who live in, public housing there, and maybe, it is biased against them for a certain reason, or it may pick up on certain ethnically charged names, right? Or all kinds of weird things. Like, it's what's weird about training these models on data is sometimes you don't know. So while I definitely think it can help, I'm not sure how far the explainability can go. I mean, look, sometimes humans, I would say, there's very few people in the world who would say, yes, I'm racist, but there are a lot of people who frequently accuse lots of other people of being racist. We see this all the time publicly. And what happens is some celebrity or something, they say something that someone feels is inappropriate. Somebody points out that it's racist. They initially say it's not racist, or that's not how they meant it, or whatever. Eventually they just end up apologizing. But like, my point being, humans don't always agree on something like that, right? Like, humans sometimes disagree on whether something, there's certain things we would say are definitely racist. There's certain things, there's a big disagreement about like the, having the Washington Redskins as a name or something like that, right? And so, when you look at those things, and you can't always get humans to agree, and there's a lot of human argument about it, and we're supposedly the standard for high intelligence. Well, and sometimes we can't explain it, right? It's like, why did you say that thing that was offensive? And you're like, well, I kind of don't really know, or I didn't intend to do that, or that wasn't my intention. Like, it's, how well can the machines do? Like, my hope is that someday they do better than us, but it's hard to see. It seems like there'll be a lot of missteps before we get there.
So talking about this complicated relationship between humans and machines, I'd say the equivalent of, a Luddite in 2022 is someone who believes in this, bot apocalypse, and, the bots are out to take jobs, and, sky's falling. I contend that, they're being on the wrong side of innovation.
Yeah.
So fast forward 10, 20 years, what does that relationship look like between humans and machines?
It's interesting. I do believe that technology has always displaced sectors of the economy and will still happen. I also think that new jobs will pop up. Uh, and and look, there are these things like humans are always looking for status against one another, and so just being able to have humans. So let me give you an example. We used to all ride horses, right? Having a horse was not a big deal. Now, I don't know if you know any horse people. It's a hobby you can only get into if you're very well off, right? And that happens with a lot of technology, which is tech makes something. We always used to make our clothes by hand. Technology made it easier to make clothes. Suddenly we could all have nice, well stitched together, stylish clothes. Now it's a show of status if you can have a handcrafted suit, right, or whatever. And so these things come back around in different and unique ways that aren't always predictable. And so I think, is it feasible that someday machines are better than humans than everything? Yeah, it's definitely feasible. It'll probably happen at some point. I don't know if it'll happen in my lifetime. I think it's definitely a long, long way off. If it happens, are there no jobs for humans? I'm still not convinced that's the case, right? I think there'll be some people that just want to work because they like it. There are things people do, like, look, I play piano as a hobby. I do it entirely for fun. Some people do it as a job, right? There are things that cross over. I'm sure, some people love writing code. I'm sure there's some people that'll write code even if machines can do it all. So it's going to be really interesting, right? I agree to your point. I'm not worried that we're going to have this rapid transition and suddenly there's no jobs for humans and we don't know what to do. But I do think we have to be smart about constantly retraining, and figuring out, there's a really interesting company that I invested in called AdeptID, ADEPT, and they, what they do is they use machine learning models to match job codes together that might not be obvious. So, everybody's like, oh, you can't be a coal miner anymore. You should be a programmer. Like, look, programming isn't for everybody, for particularly people that like to work with tools and work with their hands. Like sitting behind a screen all day, looking at blue light, it's like going to make their eyes glaze over. But it might turn out that, like, if you were a good, CVS cashier, you might be a good flight attendant. They're both about being personable, right? About interacting with the public. Maybe if you were a good welder, you might be a good, I don't know, something with phlebotomist, right? Or something where, maybe you're good with your hands. You can draw people's blood. You can do whatever. So they do those kinds of transitions, which previously would have been really difficult to do because you have to know so much about so many jobs. By putting all that off on a computer and on an algorithm, it actually brings it allows you to do this at a scale that you couldn't do before. So they're having a lot of success. And I think you're going to see a lot more tools like that and approaches like that down the road. But not really worried about the bot apocalypse in the near term.
So let's say, and call it, maybe it's 40 or 50 years, we achieve AGI, artificial general intelligence, and let's say, the bots are sentient. Even if we get to that point, which is certainly debatable, what does it mean to be human? What are the things that when we're surrounded by thinking machines are an innate part of the human experience?
Yeah, probably suffering, right? If some people still want to do it. I mean, it's interesting, right? Because the Elon Musk approach here is, hey, Neuralink, we're going to augment ourselves. We're going to become like the bots. And then I think the human experience is going to split into two pieces where you're going to have a lot of people that prefer to live in the metaverse, right? Which is where I think the robots are going to spend most of their time because it's going to be way more interesting than here in terms of what is possible. And so, but I think there's still a physical experience for some people that that they get that's hard to explain from nature, from being around other humans. I think it depends a lot on, look, people are different, right? They're different in what they like. And I think you're going to see a broad continuum of experiences. And I think you're going to see a lot of people that are, I think you're already starting to see some technology I wouldn't say it's Luddites, but there's a lot of rejectionism, right? Where people are just like, hey, I don't need the next thing, or I don't like this about technology. And technology, the last couple of waves of Web 1 and Web 2 have not been about, I mean, some aspects of them, like Netflix, have been about like personalization or whatever, but largely they've been technologies that can apply broadly. As technology applies to itself and starts to, through machine learning and AI, make technology itself easier to create, then, and as AI starts to allow personalization at scale in a whole bunch of areas, I think you're going to see this very broad continuum of how people interact with technology, where some people continue to reject a whole lot of it. Some people embrace as much of it as they can, as deep as it can go. And then everywhere in between, right? Where people are going to figure out the part of their lives that they want to apply to AI and the parts that they don't. But I don't, I'm not even sure now pre-technology how I would define what it means to be human. So I don't have a good answer for you in that day and age either.
Maybe in another podcast, we'll explore that topic in a little more detail. And thanks for indulging me. This just became a philosophy podcast. Well, Rob, I got to get you off the hot seat in a few minutes, but not before answering one last question. So you mentioned you've invested in somewhere north of 100 companies, and I know from reading the newsletter that you see a lot of interesting, innovative applications of AI. The thing that sticks out in your mind is kind of the AI moonshot. You couldn't stop thinking about whether or not you invested, but something that came across your desk that you said, it's going to change the world.
Yeah, that's really easy. It's a company called Mythic. And the first time I met the CEO, Mike Henry, we were at a dinner together on the West Coast. I'm based in Boston, but I was out in San Francisco for some meetings. And this was probably early 2016. And, I'm a hardware engineer by training. So I was talking to Mike about what they were doing, and he was telling me how they built this analog AI circuit. And so just to back up for your listeners, there are lots of different ways to do compute, actually. And most people don't understand. I mean, an abacus is a computer, right? And there are lots of ways to do it with electronics. You can use analog computing, where you use a lot of, you just use voltages and resistance and different things like that. You can do spiking, neuromorphic computing. There's a whole bunch of ways. 98% of the computers you use are probably, and the circuits in them are digital, right? And that's been the standard for a long time. We've been tied to this von Neumann architecture in the way we think about compute, and all of our tools and programming and computer chips are sort of built around that. So I met Mike Henry at this thing, and he's telling me about this analog approach to neural networks. And I remember thinking, the first thing I said to him is like, look, sorry, dude, I'm an electrical engineer. You can't do that. That's impossible. So when he realized I actually kind of understood what he was talking about, then he got really excited and he started going into the details. And I was like, oh, actually, that's pretty brilliant, like the way you guys figured it out. So their analog compute model is interesting because analog compute uses way less power and is much, much, much faster. So you take the type of compute power you would have in a typical NVIDIA server card, and you put it in a $30, 1 milliwatt package or whatever. I don't know what their specs are for it right now. So what's interesting about it is not just because it has a lot of applications for AI and running AI at the edge and doing it more cost effectively and in low power and everything else. What's interesting about it is when that paradigm, when chips like Mythic, and they have some competitors as well, when those chips get out there in the world and people start writing for those chips, and you have 5, 6, 7 years of people who have been in grad school or come out of grad school and worked on these, and these chips' capabilities are their main way of thinking about the world, they're going to come up with ideas for these chips that they can extend them to that we didn't ever think about, right? And to me, that's really, really exciting. It's a lot like, companies, when the web first came out, people thought of, the web as, hey, this is our online brochure about our company, right? They didn't think about it as actually building tools and software and interactions and communities and all that. Like that all came later. as people were more web native and all that. And so the same thing's going to happen with these different forms of compute that AI is driving, is as people work on these different forms of compute, they're just going to, it's just going to unlock so many different things that we can't even imagine right now. And I just find that super, super exciting to think about what some of those things could be.
Well, Rob, we managed to discuss almost zero of the topics we planned to discuss, and this has been a fascinating discussion. So we'll definitely have to have you back for a sequel. What do you think about that?
Yeah, happy to do it anytime. So yeah, maybe we do it in person next time post-COVID.
All the better. The sooner the better.
Yeah.
Well, Rob, this has been so much fun. Thanks for hanging out, and really enjoy spending time with you, and look forward to the next conversation.
All right. Thanks for having me, Dan.
This is your host, Dan Turchin of AI and the Future of Work, signing off this week, but we're back next week with another fascinating guest.